Hello everyone. So this is my new tutorial. So I made this one for RBD. So in this tutorial I'll show you how you can use deforming objects, or you can say animated objects, as a collider, and how you can use a simple glue constraint to stick the objects, and many more things to cover in this tutorial. So I'll start by taking a FPX. I downloaded it from Maximo, which is from Adobe. So they gave us very nice, you can say, animated characters, which you can use for commercial and non-commercial, but you can't sell them. So that is like very good thing, because if I have to make a tutorial or I have to make a show reel, so it is very difficult to first animate all the objects, then so I can get something more like this. So the issue here now, the size of the object is so high. It is around 50 around 170. Yeah, it is so big. So, and it has bones and binding and everything. So I have animation of around 1 second. First I'll say best default. Okay, so we have this animation. So this is around how much frame? 85. So I'll take around 110 frames maximum. Apply. Yeah. Yep. And now I need this character to only this character with animation, not with bones and everything. So I'll show you what is inside this FPX subnetwork. So see this much thing which is not needed for me. So this is nothing, just bones which are animated with the nulls, and this is same like whatever we do in Maya, same hierarchy and everything. So I'll not go on that now. So we have materials, leave the materials now. So we have this is the main thing. So see, if I'll do hide other object, so you can see now I can get only skin. So what I will do, I'll create a null here, null, and I'll give it a name of skin, or maybe character. Okay, so now I'll create okay, outside, okay, control B. I'll show you what I'm doing. So I'll create a new geo node. I'll rename it to character. So and this one, which is I'm never using, or which is like yeah, which is not that much important. It is important, but I will not use this thing, so I'll make it red, and this time I'm using, I'll make it green. Yep. So inside this I'll create a object merge. Object merge node is used to call any other node from other nodes, inside nodes. Like inside this I want this node, so for calling that I need that object merge. So what I'll do, I'll go to object merge, I'll click here, and I'll go to that character accept. So now if I'll go to one sec, yeah, so now if you'll see I have this, and I'll go and hide this one and non-selectable. Yep. So this one, so I have this, but still there is a issue. This is so big. So in Houdini we need our character to be a proper scale. In Houdini or in any software, whenever you are doing dynamics, you need your character to be proper scaled. So as you can see, I have a Houdini Tommy, this test geometry. So this is around, one second, I'll show you. Yeah, two. Yep. So it is like 1 meter. This is 1 meter and half, more than half, means 1.75 meter. It is okay. So I need this scaling to be same like this. So what I'll do, yeah, so I'll just put this one and I'll put a transform. Okay, transform node. Yep, and I'll scale it down focus, and again it will go around 0.01, I hope. Yeah, maybe 0.012. Yeah, yeah, this is proper scaled. Yeah, this much is enough, so I'll delete this one, not needed. So as you can see, yeah, so this is our geometry. And what I'll create a wall, and when it will go and hit that, so wherever it will hit, that portion will broke, like in action films. Yeah, so this will be our geometry. So I'll go for smooth shaded. Yeah, now it is okay. So I'll create a null, and I'll rename it as a collider. Yep. So we have our character which will fight with that, and now I need a box. So what box will do, I'll make a wall from this. So I'll go for that animation first when it will hit. So it is, yeah, this frame. So now I can go and make our object like this. Sorry, this side. Then I can make it a bit up. I can scale it up around 3, and this will be 1.5. I'll move it to this side, and I'll scale it a bit down, like 0.05. Yep. And yeah, this is okay. I to reduce a bit of height, like 0.75. So what you can do, you can copy this parameter and paste, but yeah, this also. So I have to move manually, I hope. Like to yeah, a bit of work. So maybe this thickness I'll make it 3. Yep. So this is my thickness, and just check. I will make it a bit more this side. Yeah, this is right. And then again he will hit his head also. He's alien. And his leg also. So first of all, I'll create my project. Okay, I'll create a project directory. I never show you how to create. So what I do, I'll go for a new project. I'll find wherever I want. So I have a folder of YouTube tutorials. So I'll create here, and this is RBD tut. So if I'll say accept, and then I'll go and set project, Houdini project RBD, and accept, and I'll save this file. Oh, okay, set project. Yeah, it is done. So if I'll save it to job, yeah, so I have to write RBD tut underscore version 01. So it is saving. It is good to save, maybe because it will be maybe a bit long tutorial, so if it will crash, then it will be problem. So we have geometry, we have our wall. So now we'll see how we can use this wall and break this one. So hide the object. Yep. So first of all, we need some point to scatter. So I'll use a scatter node. Yeah, so we have this, and yeah, I need some point inside also. So I'll use a ISO offset, which will, what it will do, I'll show you. Yeah, so what ISO offset, it will convert it to a fog volume. So if you increase the division, you can see it properly. Yeah, and now if you will scatter, so you will get some point inside also. Okay, and before maybe you can see this. See, there are points inside, but when if I'll remove this, then there is no point. So this one, and I'll decrease this point to 250, and then I'll take a voronoi fracture, put it here. So first input will be geometry and second will be the points. I'll select this and visualize. Yeah, so this is Voronoi pattern. So the main thing is I'll show you point. So if I'll create an assemble node, you will get it, and I'll create a pact SW and yeah, okay, there's some issue, window F. Okay, I have some report error issue. So the main thing is I'll tell you. So the points, these are Voronoi cells. So we have a point here, 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 and the distance between those are always equal. Like if this point has a center here, and this one here, this one here, this one here, whatever it is touching, so the distance is always same from the centers. Okay, so this is Voronoi pattern. So I need even, yeah, this is okay for now. So what is assemble node? With assemble node, I'll go to geometry spreadsheet. So till here it is like this. So we have a name attribute in a primitive level and in position. So in assemble we'll create a remove this, a name attribute for the point. It will create on point. So we have total 249 pieces, 250 pieces, sorry, 0 also, and then we'll create packed geometry. So what packed geometry will do, so before, you can see we have a lot of vertices. I'll take exploded view. Yeah, so you can see we have a lot of points, and when we do pack, so it will be 1 point per cell, or you can say this is now one primitive. This is one primitive, this is one face. If I want to select this one, so this is one face. Before, if I want, I can select separate faces and delete and move and whatever I want, but now it is a single polygon, a primitive, and it is driven by a single vertex. This inside vertex, whatever you can see, point, sorry, not vertex, point. So yeah, so we did assemble. Now we'll create a null and tell this one that okay, you are RBD, yeah, RBD source, or maybe we can give wall, whatever naming. So now we'll create a .NET. So now we were in this is object context, and this is geometry context, and this is dynamics contrast. Whatever dynamics we are doing, we can do here. Now even for now they created many SOP solvers also. So SOP solvers means not SOP solver, means dynamic SOP. So you can use them and do RBD and everything. So for this one in dynamics, what first we need, we have to create a VDB packed object. Sorry, RBD packed object. So what is RBD packed object? So whatever we created here, box. So this is packed. So for importing that thing and give it some attributes like what will be the position, rotation, everything we can give here, and we can give this collision thickness and everything. So what we have to do first, RBD packed, and we have to call for that. So I'll show you two method of that thing. Maybe you people know, but I'll show you two things. So first of all, minimize this. Yeah, so this box one, and we'll create this, select this RBD, and if you click you can see this one. So this is one way to call it, and other way is, you know, this. So maybe you saw in tutorials, it is dot slash, then you can go box one, and then you can select this, what is name, RBD, yeah, RBD source. So this is two, and what does this mean? This means you are going one step back. From this one you will go to this, then you will go again back, then you will find this box one, then RBD source. So both the thing you can use, but if you know, that is better, because in the starting I was very confused about these things. So after that we need a bullet solver, or I can use rigid body, because rigid body is nothing but the bullet solver. If you go inside, you can see we have multi-solver. Okay, so see, we have a bullet solver, we have a voronoi fracture solver, and we have a this one bullet solver. Yeah, so we have all three together in this one, and if we want, we can use directly a bullet solver. It is same, you'll get the same settings, whatever this has, same setting this has. So I prefer rigid body solver. And then we need a gravity, and we'll connect it to output, select it, and now I'll play. So as you can see, there is no ground plane, so first we'll create a ground plane. Yeah, so I'll create a ground plane, and I'll create a merge, and first input will be ground, second will be gravity, and then and always remember this, when it is using as a collide relationship, so it matters a lot, first second input, because the relationship is left input affect right input. If you will do it mutual, it doesn't matter, you can first plug this, second it will Houdini will automatically calculate that what it has to do. But if you are doing in starting, so if it is left input affect, so first input should be your ground, second will be your RBD objects. So now if I'll now if I'll show you, okay, so it fell down, which is not right. Yeah, it isn't right. So now I'll introduce something new. It is a multi-solver. Multi-solver is nothing, just you can plug multiple solver in that, and by the order it will calculate it. So I need a soft solver. I'll show you why I am doing this. Yeah, so in soft solver, go inside. So this is our soft geometry. So what we will do, we'll create a group, which will be a point group. Okay, and we'll go for a bounding region. So select this one, you can see bounding box, and yeah, just I'll tell you why I'm doing this. Yeah, this is pretty good. Yeah, this much. So after that I'll create a primitive wrangle, a very small code. What is this? Primitive wrangle. Okay, yep. So I got a primitive wrangle, and there is a very small code. First we'll select that group. This is group 1. It will go run on the primitive also, point also, it doesn't matter. So it is I at active is equal to 0. What does this means? First to see what is happening, then I'll tell you what does this means. Now if I'll play, okay, one second, shit, should be, yeah, now if I'll play, yeah, so as you can see everything fell down, but these are static. These are static just because there's an you can see here, maybe this is an point attribute active. So what is active? Active means whatever in this area, I said in this soft solver, whatever in this group, first I created group. Why I took point? Because these are packed, so I can select them by point only. Okay, after that I said whatever I selected in the group, I need that to be inactive. Active is equal to 0 means inactive, so they will not move. Yeah, so now, okay, we have this. Yeah, so now I need a static object, and I'll merge it, and why change the order. Yep, so okay, we didn't find that because I have to go and I have to find that character. Collider, accept it, press it. Okay, so if I'll play, it is not moving because I took a static object. So you have to use deforming geometry. You have to just click on this one and it automatically, you can see it is colliding, as you can see. See, it moved a little bit objects, but our geometry is falling before. Until even it is inactive, still it is falling. So what we will do, I'll create a constraint network manually. This box I'll rename it to wall, maybe. Yep. This one also green, and this one will be purple, maybe orange. Okay, so go wall. Okay, so constraint network is very easy to make. So what we have to do after this assemble node, we have to create a node known as connect adjacent pieces. So you can see these lines, colorful lines. What they will create a constant network. So first we will increase the connection and the radius. You can see you got something. So I'll go for 12, I hope. Yeah, so we have a very powerful connection. So how it work? So for after this, we have to told Houdini that okay, we created a network and this is a constraint. So this is as a constraint name is equal to anything you can give here, glue, and as at constraint type is equal to all. Yep. So now what I did, I created primitive attribute glue. So our constant name is glue, as you can see, and type is all. All means rotation and position. It will work on position and rotation both. Then I'll create a null and I'll rename it to constraint. So now how I will plug this thing to our .NET. Simple. What we have to do, after this multi-solver, we have to create a constraint network. Plug it here. Yep, it is showing error because it needs something to create. So I'll create a glue constant relationship, and I know the name is glue, correct, and I have to go and find where is that. So it is in wall constraint and accept. So you can see we got this red network, which is constraint network. So I'll first play this. You can see now it is not falling. Yeah, and now it is not even breaking when even he is hitting, because this value is so high. So if I'll make it less, you can see it broke the wall. Okay, it looks cool for now. Yeah, so okay. Yep, I'll set a camera also for this thing, maybe. Yep. Okay, so for setting camera it is very easy. Just you have to frame whatever you want and go to new cam and select new cam. Okay, and go inside .NET. Yep, and play. Yep, it is broken. And see, after that, when his knee, so I'll show you there's some issue. They are not falling down now. As you can see, they stuck in the air. So there could be two things. So first of all, I'll check this is our RBD path, and we have to check the, yeah, see these things. This is our collision geometry. This, I'll go and decrease this padding to 0.01. Go to first frame. Yeah, it is okay. So this is not the issue. If I'll play again, you can see they're not falling down. I'll tell you why they are not falling down. they're not falling down just because uh, we created this soft solver, and you can see our group, so this much big. So whatever is coming inside this when simulation is going on, so that is also getting value 0. So what I'll do, I'll decrease this, not this, but this size a lot less. I'll move it and make it up. Okay, so I'll go from the view, so it is easy. Just perfectly I'm trying to do this thing, and yeah. So in this view, you can see I can do like this, and I can move it a bit. Now again select this thing, and I'll go and our display our geometry and hide this thing, and I'll play. So boom. Yep. Make this 0.02, maybe that was right. Yeah, this looks cool, and this is broken. So now I'll show you 2-3 more things. So first of all, they all are like one piece. This is one piece, but whenever one wall or something is falling, so we have clumps. So how to create that, clusters or clumps, whatever you can say. So 2-3 things you can do. First of all, you can increase the fractures. I hope. Okay, I'll go to here. Doesn't. I'll go for 1000. Okay, because I need more points. Yeah, so this is cool, and I'll remove this. So when you created this connect adjacent pieces, so before that you can create cluster. So in older Houdini we have a tab inside the voronoi, so you can create cluster there. Still we have this RBD cluster, you can see here. If you connect this one, and I hope you will go to this visualize, so you can see these are clusters with the same color, but I don't find this useful that much, so I created by my own. I'll delete this. So I create a attribute warp, and I'll plug it up. So what we have, okay, first of all remove this color, otherwise it will be confusing. Yeah, so now we have position, so we'll take a node voronoi. We have this voronoi, so we'll plug this position to position, and this we have seed. So if I'll directly plug this seed to color, you'll see black. So I need a random, yeah, so now it is black and white because it is 1D integer input and 1D output. So I need 1D integer and 3D output. So these are now clusters. So you can go here and play with this thing, you can increase it, see, you get more and more colors, and these colors will be your cluster. So I'll try to make a bit more because I need a small cluster, so I'll go for maybe 3.5, and 3.5. Okay. Yeah, so we got this, and what we have to do, whatever seed we are getting, we have to export this. I need this thing. This is for display purpose only. So I need this thing, this bind. So I'll write a name cluster, and I'll export this parameter. So as you can see, we have a cluster. Okay, this color and name is everything. So I'll go outside in attribute warp. So now first of all remove this thing. So what we'll do, we'll find the points, or I saw multiple ways to do this, but I hope this one will be better. So we have attribute warp. So it is, you need a prim point. Okay, so you can press F1, Just press F1 and whatever, doesn't work. Ooh, okay, it came. So I'll go to here and I'll press F1. Yeah, you can see. So geometry, prim number and vertex. So our geometry is 0, prim number is at prim num comma 0. Okay, so now I need vertex point from this. Vertex point, okay, not like this. Again same thing, you can press F1 and you can see what this does. Press F1, yeah, we get. So we need a geometry and linear vertex. So from this one, okay, sorry, I did something wrong. I need this prim vertex, yeah, and after that we need this 0 comma, we give this prim vertex and we have to close this bracket out, yep, and I'll go to home and go for integer point 0 is equal to, I'll tell you first, I'll check this one once, okay, and copy and I'll paste it, and I'll go to 1 and home and create 1. So after that I'll do, and then I'll tell you what does this mean. Just a 0 point 0 comma cluster comma pt0, and I'll copy this one again and enter paste. I'll go for 1 and 1, and then I'll create this if cluster 0 is equal to, maybe it is so difficult for now, but I'll tell you what this does. So constraint name is equal to glue inside else at constraint name is equal to glue outside. I'll check because in scripting if I'll do one single mistake. Yeah, so we have glue inside outside, this is right. Yeah, so I'll check it once, is it right or not. So I'll go and I'll blast and I'll write here as at not at constraint name is equal to glue inside. Nice, I did it. Yep, so we got this one. So I'll tell you now what I did. So what I did, first of all, with this prim vertex, I'll tell you what these functions do also. So press F1. So what a prim vertex function do, when it returns a linear vertex index corresponding to the given primitive vertex, returns -1 cannot, okay. So what it will do, it will find the vertex of that primitive. See, on one primitive there is two vertex only, mean primitive line. If we have a line, so we have two, so one and it will be 0, one will be 1. So what I did, you can see here. So first of all I did 0 first input, okay, then primitive number which is at prim number, okay, correct, and vertex. So I need for 0, I am storing the value of vertex 0, okay. Then what I did, vertex point, so I'll find then, okay, I'll show you what is vertex point, sorry. So what vertex point, the point number associated with the vertex or -1. So whatever the point associated with this vertex, I'll get this, means in this full function, first of all we'll find the vertex on the primitive, then point on that vertex, okay. So then we'll store that value in point 0. Same thing for 1. Then we'll create a new attribute cluster 0. So what it does, So I created a point function for that one. And what point function do? I'll show you what is it in return. Oh, what happened? Point fun. Oh. Okay. So what this function do? Point function. It reads a point attribute value from a geometry. So we have a geometry. We have a value of cluster. So we want to read. I want that to read the value. So and what does this do? Correctly, I'll show you. Okay. So see, if we'll see this side, this is okay, but wherever it is changing color, like here it is yellow and here it is white or beige, maybe it is beige. So these, so I don't want this one. I want this color to be a cluster, this pure color to be a cluster. Wherever it is like giving two different color, like green to other color, blue to other color, red to another color, any other color, then I want that thing to be separate and this thing to be separate. So what I did, so after that I did cluster 0. So in this one, whatever on the point 0, find this cluster attribute on that point, and same cluster 1, find that cluster attribute on that point. After that I said if these two are equal, double equal means the remainder will be 0, means if these are equal, means if same color, then it will be glue inside, as you can see here. Yeah. So and if it is see, it is not sector, yeah, and if it is not same, if a remainder is not 0, then it will glue outside, which is this thing, inside outside. So we got this one. We'll stop, we'll now create, so we have two constant now. What is, one is glue inside, what is glue outside. So I'll go to .NET. So how it will work now? Nothing. See, this thing is same, just you have to copy this one, okay, and I need it to be merge, and I'll merge these two, and I'll go for this one. So here I have to change the name, glue inside, and this will be glue outside. Yep. And you know, you can visualize this here. You have these two, so what you can do, you can change the color, so you can see easily what is going on. See, this blue and this is red. So now you want this blue, okay, shit, to not break. So we'll make this one 1000 and this to break. So it is 10, it is okay. So now I'll go to out, I'll press W and I'll play. You can see what is happening now. Okay, maybe I have to increase the, yeah, I have to increase, because what happens, you can see this was a cluster but it broke because, yeah, because the value is less, that's why. So what I'll do, I'll go to glue and I'll increase it to 110,000. And this is your artistic decision. Yeah, see, this is one clump, and if you want it to fall again, fall and break, so maybe you can decrease this value to 5000. Now I'll check. So you can do a lot of things. Yeah, yep, yeah, this look cool. So it came, then this thing again he did. So maybe this is still too high, because I want them to break when they will fall down. So again, so as you can see, they are still constant. If you press W, you can see these are constants, these are constant. So yeah, I can like this one. Yeah. Okay, I got a value 3000. Maybe this one will be perfect. Yeah, this is okay. I got some big pieces, some small pieces. Okay, got stuck there. 2500. Yeah, so this is the result, and his head is inside this, as you can see. Lol. See, his head is inside this. It is getting a perfect shape also. So it could be some problem with the this thing. So go and check its collision. Yeah. So as you can see, this collision is not proper. So yeah, this thing. Yeah, this is right. So I can show you now. So whatever I created before this collider, so you can do one thing. You can create a collision source node. What this do? This will give you two input. One will go for geo and one will go for VDB, which is more accurate than this normal one. So and this one will be your geo maybe, and this will be, one sec, I'll confirm this thing, geometry and VDB. Yeah, right, VDB. So if I'll click on this and press W, so you can see the resolution is so low. So I'll go to volume and make it 0.01. You can see now, and geo is correct. So now if you'll go to .NET and static, so now it is ray intersect. We have to go for volume sample, and in proxy volume you have to call that VDB. So now you see it is more accurate now. Go and hide that thing. You can hide our character also. Yeah, you can see. Maybe it is a bit slow, not that much slow, but a bit slow. But you will get more accurate result with this thing. Like that's why when you create with the shelf tool, it will always create that collision source. Yeah. And you can see still there is some issue. I'll figure it out what is the issue, but these clumps I like. After that we can put some details in this one, which maybe I will not tell in this tutorial because it is not so, I am not trying to make so hard tutorials so people can't follow. I want something like which intermediate and beginners both can do. This thing I'll find something. Yep. Okay. What is the issue? There is no, yeah, you can see how it breaks when it touches here this side, then it start break. So this head thing, I have to do something with this head. Okay, so this is not my animation file, otherwise maybe I will not make this thing, that head go inside. I can maybe make head back or something. This leg thing is correct, it broke perfectly, but this head maybe I'll go and increase the offset. Okay, first frame. So I'll remove this, and maybe I can use something. Size is okay. These things are okay, and we'll see what we can do. Okay, I can check this thing also. Maybe, yeah, maybe it's subdivision or something is creating issue. Okay, I'll play it. Yeah, play. Because if there is collision surface, then it should collide with that. So this is punch. Yeah, correct. After that, okay, we'll see. There is some issue, but that is not so big issue. We can't uh, correct that thing. We can correct that. So now I will see what is issue. Okay, so if you'll go here and see, so yeah, you can do one more thing. You can increase the sub steps also. Then also this problem. So it will collect. It will calculate 2 times the same thing. Yeah. Display geometry. Okay. So this will be our angle, and I'll create a, where is our camera? Yeah, I'll create a play blast and I'll show you final thing. As you can see, I like those clumps, whatever they fell down, clusters, clumps, whatever you say. Yeah, this is correct. Where is our, this one? You can see here. And you can see if okay, one more thing I'll mention. So you go to wall. So we have here, you can see a lot of objects. That's why that is small effect you can see. If I'll go for 500 and see, the best thing about Houdini is this. I love this thing. I have to change just one value. I have to do nothing and just see final result like this. Now you can see that hole we created will be much bigger. See, yep, I like this one much better because I need a bigger hole. That was very small, so you can feel that impact also. Even we can from those falling pieces, with the help of velocity, we can create a smoke dust effect. And yeah, I feel this one better. Yeah, this is looking nice. So I'll show you this thing. Yep, it looked nice. Okay, so we'll wrap up for now. And if you need any help regarding this, you can comment, or if you need any other tutorials, then also comment. Then I'll try to make tutorial on that, because I'm also learning with these tutorials we are making for you. Thank you.